Okay, so students, we are going to discuss this paper 5.2, okay, for October, November 2021. All right, okay, so let's have a look for question number one. Okay, so for question number one, they give you a table and they are telling you that there are 180 students. Okay, so place exactly one of the piano, guitar, or drums. Then they also separate into, according to gender, female and male. Okay, then it is given in the following table. All right, so a student at the college is chosen at random. So first, they want you to find the probability that the students play the guitar. All right, so to get the probability of students who play a guitar, so you are not going to consider whether is she or he is the student a male or female lah. All right, so you just want to focus on the probability that the students play a guitar. So it means you need to add, all right, you need to add the guitar, okay, the number of students who play the guitar together, which will become 44 plus 38 divided by the grand total. So the grand total will be 180 of students in total, right? So we are having 180, and therefore you should get 82 over 180, and you can further simplify become 41 over 90, or you can change it become three significant figure, which is 0.456. Right, so this is what you have for part one, and it's very straightforward. You just need to add the value for the students who play the guitar, then divided by the grand total. That's it. Okay, then now we continue to part B. Right, so for part B, okay, so they want you to find the probability that the student is male, given that the student plays drum. Okay, so highlight the word given that. Again, when you see the word given that, it tells you that this is a conditional probability, and your symbol for conditional probability will look something like this, with a slash in the center. Given that, what is the event that we know first? Play the drums. We already know that the student play the drums, so you should write on the right hand side of the slash. Okay, and they want to know what is the probability that the student is a male, so you write the male here. Okay, so this is a conditional probability. Therefore, when you want to find out the probability, you need to write out the formula in a proper way lah. So it should be male intersect with drums divided by the probability of the students who playing drums. All right. Okay, so for the students who are male intersect with drum. Okay, so if you want to look at it from the table, it should be male and drums. So the intersection part will be this value, which is 11. Okay, so you can put 11 over 180. So that's the numerator. And then for the denominator, students who are playing drums. So all the students who are playing drums, you should include it. So both, okay, should be included in the number of the students who play drums. So it should be 11 plus 20, and therefore you get 31. So you have 31 over 180. So if you further simplify it, you'll get 11 over 31, or you can change it become three significant figure, which is 0.355. Okay, so this is what we have for part number 2, part B. Right, and next, let us continue to part C. All right, so for part C, they are asking you to determine whether the events play the guitar and also female are independent or not, and you need to justify your answer. All right, so to prove whether two events are independent or not, generally you need to find out two values here. The first one is you need to find out the value of probability of guitar multiplied with the probability of female. Okay, so this is the first value that you should try to find out, the multiplication between the guitar and female. So for guitar part, okay, guitar means overall in guitar, so it should be 44 plus 38. And the answer you get it just now is part 1. All right, so it should be 41 over 90 multiply with the female probability. So female probability, you should add all the female probability, the number together. So for the female probability here, you should able to get 100 of them. So it will be 100 over 180. So when you multiply these two probability together, you get 41 over 162. And of course, if you want, you can change it become three significant figure. Okay, so that is easier for you to make comparison later. So if you change it become three significant figure, it will be 253, 0.253, sorry. All right, then after the first value that you get here, you want to get the second value. So the second value is you try to get the probability of guitar intersect with female. Right, so this probability you can get it straight away from the table itself. So guitar intersect with female. Where is it? So guitar intersect with female will be this one. Right. Okay, so this value here, which is actually 38 over 180. Okay, the 38 over 180. And again, if you want, you can try to simplify it also. So if you simplify it, then you will get 19 over 90. Okay, so after you get these two values, you try to compare them. And of course, before you compare them, you can change the 19 over 90 become three significant figure. Right, so you have 0.211. So you try to compare these two values here. Are they the same or not? If these two values are the same, that means they are independent of each other. So very obvious now. So for this question, you can see that the probability for these two values here are not the same. So you can write a simple conclusion here where this is the reason, right? So guitar multiplied with female is not equals to the probability of guitar intersect with female. And this is the reason, therefore, okay, therefore you can write out the conclusion here. Maybe I write it down here. Okay, so you can make a conclusion here. The students play guitars, play the guitar. All right, and the student is female. They are not having the same value, right? If you make the comparisons just now, therefore, they are not independent. Okay, so in the solution, it will be good if you can write out the reason, and after that, followed by the conclusion, which is not independent. Okay, so this is what we have for question number 1. Okay, question number 2. All right, so for question number 2, there's a group of 6 people is to be chosen. All right, so highlight the word chosen. Okay, so this is actually a combination. Choose, select, all these are the keyword for combination. So later when you answer the question, you need to use the concept of maybe the step of NCR, right? Okay, so you're having 4 men and also 11 women. Okay, so in how many different ways can a group of 6 to be chosen if must contain exactly 1 man? So the 1 man here is actually the restriction. Okay, so if let's say you only have 1 man in the group, which means you will have 4, you have to choose 1 man out of the 4. So you have 4C1. Multiply, the remaining will be women, right? So 11, from the 11 women, you want to choose the remaining into the group, which is 5 of them. So it will be 4C1 multiply with 11C5, and the answer is 1848. Okay, so this is how we actually get the answer for the number of combination, okay, for this question. Right, then after that, we have a look for part number B. So 2 of the 11 women are sisters, Jane and Kate. Okay, so now in how many different ways can a group of six to be chosen? So again, this is the keyword again. Chosen means the selection. So you are using the combination method later. So if Jane and Kate cannot both in the group. Okay, so if Jane and Kate cannot both in the groups, there are a few possible situations. The first one is Jane in the group, but Kate not in the group. Or Kate in the group, then Jane not in the group. That's the second case. Then the third one is both of them are not in the group. Okay, so to make the calculation which become much more easier, we can consider the case where both of them are in the group first. Both, okay, sorry, not Jane and Kate in the group. Okay, and for this question, they actually didn't tells you, right, for this group, how many men and how many women they need to have. So we assume that the gender is not important. Okay, so we are having 15 people originally, and then we already include Jane and also Kate in the group, right? So you still need to pick another four members, okay, four person to become the member in the group. Okay, so originally you're having 15, but you already exclude Jane and Kate from being chosen because you already fixed them in the group. Okay, so you want to exclude Jane and Kate from here, so it will become 13. All right, so from this 13 remaining person, you want to choose four of them and put them in the group. So it will be 13 C for 13. You want to choose four person. Okay, and then the number of ways that Jane and Kate both not in the group. So if you want to, oh sorry, cannot be like that. Sorry, the Jane number of ways that Jane and Kate cannot both be in the group. Okay, sorry, the meaning is different now. So cannot both be in the group. That means you need to take the total selection without looking at the restriction. So the total selection will be 15. You want to choose 6 of them, and you minus the case where both Jane and Kate in the group. So it will be minus 13C4. Okay, so 15C6 is the total number of selection without any restriction, minus 13C4. And from here, you will get the number of way, which is 4290. Okay, so this is the answer for question number 2. Okay, let's discuss question number 3. So there's a bag contain 5 yellow and 4 green marbles. Then 3 marbles are selected. So again, you see the keyword selected. So please highlight the keyword selected here. At random from the bag without replacement. So without replacement is also one of the keyword. Okay, so the 3 marbles will be selected. So the selected also tells you that it is kind of the question like combination. Okay. Then now for part A, they want you to show the probability that exactly one of the marble is yellow is 5 over 14. Okay, so now the probability that they want you to find out is one yellow marble. Out of the 3, right, there's only one yellow marble. Okay, so because of the keyword selected, right, and to find out the probability, okay, I'm using the combination method. So one yellow means that out of the 5 yellow marble, you want to choose only one of them, and then you multiply it with the rest. So the rest will be green color. So which means that for green color, you want to select 2 of them and divided it by the total selection without any restriction. So in total, you're having 9 marbles and you want to choose 3 from them. All right. Okay, so by using this method, and then you just try to press the calculator and should be no problem that you get the answer, which is 5/14. Right, so this is what we have for part 1, part A. Okay, so they might have some students asking for other methods. So some students, they might think like this. Okay, so there's another alternative method, which is considering the probability. So let's say they are going to consider one yellow means that yellow, green, and green. So if you want to consider yellow, green, and green, first one is yellow. That means that you are having 5 yellow out of the 9 total marbles. They are looking at the probability first straight away. Okay, so the first one is yellow means 5/9. Multiply with the second is the green marbles, it will become 4/8. Why is it become 8? It is because of just now you take out the first yellow marble already, so the total marble now become 8 only. So it will become 4/8. And then the third one is also a green marble, then you will have 3. Okay, why it is 3 not 4 anymore? Because the second marble is green color and you take it out just now without replacement. So the remaining green marble now become 3 and the remaining total marble becomes 7. Okay, so you can do it in this way, but please take note that if you list it out like this, it means that you are only considering the case which is yellow, green, green. And you need to consider the other cases that might also have only one yellow, such as you might have green, yellow, green. This is also actually actually one of the result of one yellow. And then you have another case which is green, green, yellow. All right, so in short, right, you have to consider the arrangement. Okay, if you want to use this method, the probability method, therefore you need to multiply with the permutation. So for permutation, you look at the general case here. You're having 3 items here, 3 factorial, but 2 of them are G and G means repeated, the identical values or the identical items. So you have to divide it by 2 factorial. So end up, of course, you will still have the 5/14 as the final answer. So this is the alternative way. Right, if you want to use the probability method straight away, besides list out the probability, you need to consider the permutation for the possible cases as well. Right, so to me, this combination method will be more straightforward because you no need to consider the permutation part. All right, so for the remaining steps for this question, I will focus on this combination. All right, okay, so let us continue to the next part. All right, so continue to part number B, part B. All right, so for part B, they give you a definition for the random variable x. All right, okay, so what is the x? X is the number of yellow marbles selected. Okay, they want you to draw out a probability distribution table for x. Okay, so just to take note now, x is the number of yellow marbles. So which means the answer that we get is in part 1 is actually x equals to 1. The number of yellow marble equals to 1. That means 1 yellow marble, right? Therefore, you need to actually try to figure out first what are the possible values for all the x here. When you select 3 marbles, it is possible that you get 0 yellow marbles, 1 yellow marbles, 2 yellow marbles, and 3 yellow marbles. And you need to find out the probability for x equals to 0, 1, 2, and 3. Alright, so I will start with x equals to 0. In part 1, when we use this method to get x equals to 1, it is proven that the answer that I get is correct. Therefore, for part B and so on, okay, I will still using the same method, okay, to find out all the remaining probability for x. So for x equals to 0 means that no yellow marble. That means 5C0 multiply with 4C3 divided by 9C3. So that's the value for x equals to 0. And after that, I want to get x equals to 1. X equals to 1 is actually the answer that you get already in part A, so you can skip it. Then you proceed to x equals to 2. So x equals to 2 will be 5 yellow, you want to choose 2 of them, multiply with 4 C1 then divided by 9C3. Then the last one will be x equals to 3, which means that all the marbles are yellow. So 5C3 multiplied with 4C0 divided by 9C3. Okay, so for all the probability here, you can just press the calculator and try to get the answer. First one, you will get 1 over 21. For x equals to 2, you should get 10 over 21. And also for part 3, you should get 5 over 42. All right, then after you complete the calculation, then we can try to compile everything into a table form, into a probability distribution table. Okay, so you are having x and then the probability. X can be equals to 0, 1, 2, and also 3. All right, so for x equals to 0, the probability is 1 over 21. For x equals to 1 is 5 over 14. Then x equals to 2 is 10 over 21. And the 3 is 5 over 42. All right, so this is the complete answer, okay, for part B. All right, so to double check your final answer, right, you can actually try to add up all the probability together here and see whether is it equals to 1 or not. If it is equals to 1, that means that your answer very likely will be a correct answer. But if let's say the answer is not equals to 1, that means that your answer definitely is a wrong one, something wrong in your answer. Okay, all right, so this is a small step for us to double check our probability whether is it correct or not. Okay, so this is what we have for part number B. Let us continue to part C. After you get the table, they want you to find the expected value of x, which is the mean. Okay, so to find the expected value of x, it can be very, very straightforward. So that means that you are taking every single value of x multiply with the probability. Okay, so you take every single value of x multiply with the probability and you add them together. So 0 multiply with probability plus 1 multiply with probability and so on. Okay, so if you didn't do any careless mistake again, then the answer that you get for this particular question will be 5 over 3. Of course, if you want, you can change it become 3 significant figure. Right, so for me, I will just keep it in the fraction form. Okay, so now we proceed to question number 4. Right, so part A. In how many different ways can the 9 letters of the word telescope be arranged? Okay, so again, highlight the word arrange. Arrange means that it is related to permutation. All right, for permutation, your steps might include something like NPR, and then you have something with factorial sign and so on. Okay, right, so you want to arrange the letters telescope. So from telescope here, if you try to list out, there are 9 letters. So you have 3E. Okay, 1T, 1L, 1S, 1C, 1O, 1P. Okay, so you count 3, 4, 5, 6, 7, 8, 9. So 9 letters in total, and 3 of them are E, which is identical. All right, so when you want to arrange them, it will be 9 factorial divided by the 3 identical E. So need to divide it by 3 factorial. So 9 factorial divided by 3 factorial, the answer that you get should be 60480. Okay, so this is what we have for first part, part A. Very straightforward. Okay, then now we go to part number B. In how many ways can the 9 letters of the word telescope be arranged? So again, you see the word arrange again, so that there are exactly 2 letters between the T and the C. Okay, so again, they are still considering the arrangement, just that now they give you more restrictions. So the restriction is this one. There are exactly 2 letters between the T and also between the T and C. Okay, so let's have a look. Maybe if I draw the space out 1, 2, 3, 4, 5, 6, 7, 8, 9. If let's say your T is here, then the C must be exactly 2 letters away. Or sorry, should I say 3 letters away? So there must be 2 letters between the T and C. Okay, so and you want to arrange the rest of the letters as well. Okay, so let us try to consider the possible position for the T and the C first. So this is our first position. Okay, and then you can also have T and C here, which is a second possibility, possible location position. Then the third one will be this one, right? Then the fourth one will be this, the fifth one, and the sixth one. So which means that if let's say we want to have exactly two letters between T and C, right? There are 6 possible positions that we can place them, okay, when we want to arrange the 9 letters. Therefore, I will have 6. So the 6 is for the position, the possible location or positions that we want to place the T and C. And at the same time, I need to multiply it with 2. Why do I need to multiply with 2? Okay, so the reason is because of besides the T and C, it is possible that we are having this one also, C and T. All right, so again, the same thing happen now. You can have C and T here, then C and T here, and so on. Also 6 position, so 6 multiplied with 2. All right, so the 6 multiplied with 2, okay, 6 is the position that we want to place the T and C with 2 letters in between. Then multiply with 2 is the possible cases is we are having TC and CT. All right, so once we settle the position for C and T already, then now let us try to put in all the other letters. Right, assume that the T and C is here. What are the remaining letters that we need to arrange, okay, for all the space here? We are still having 3E. Okay, we still have L, S, O, P. So you can see that all of the letters here, we still have 7 letters remain. So we want to arrange these 7 letters in a line. It will be 7 factorial. But you still can see that there are 3 identical E. Therefore, you need to divide it by 3 factorial. All right. So this part is for the remaining letter. 6 is for the position for the T and C with 2 letters in between. Then multiply with 2. The 2 is because of you can exchange the C and T lah. Alright. So by multiplying everything together, you will get 10080. So this is how we actually arrange what they want here. Okay, so this is how we solve question number 4. Okay, so now we discuss question number 5. Okay, so in a certain region, the probability that any given day in October is wet is 0.16. So they give you the probability that a particular day is wet, which is 0.16, independently of other days. Right, so for part A, they want you to find the probability that in 10-day period in October, fewer than 3 days will be wet. Okay, so for this question, you can see the structure of the question is you are having a bigger number of n days, which is 10 days here, and then fewer than 3 days, something happened. Right, so this is actually a binomial distribution question. Okay, all right, so x will be actually the number of wet days. So the number of wet days, if you want to define it, all right. And then you know that it should be a binomial distribution, binomial distributed, the n is 10, and the probability for wet is 0.16 for any particular day. Okay, so for this question, they want us to calculate the probability for x smaller than 3. So for binomial distribution, x can start from 0, so which means that you need to list out the probability for x equals to 0, which is 10C0, 0.16 power 0, and 0.84 power 10. How to get the 0.84? You take 1 minus 0.16. So the 0.84 is the cube. Okay, then plus the next value will be x equals to 1. So it will be 10C1, then 0.16 power 1, 0.84 power 9. And the next value will be x equals to 2. So 10C2, 0.16 power 2, and then 0.84 power 8. All right, so for this symbol here, they are saying that fewer than 3 days, which means the 3, x equals to 3 will not be included. Therefore, we will stop our calculation here, all right, until x equals to 2. So by just pressing the calculator, the final answer that you get for this question should be 0.794, correct to 3 significant figure. Okay, so this is what we have for part A. All right, then now we continue to part number B. Okay, so for part number B, they want you to find the probability that the first wet day in October is 8th of October. Okay, so highlight the keyword first. So first wet day means that in October, every day they want to know the first wet day in October is 8. So the concept here is kind of like when you are having an event. Okay, so you are looking for the number of days up to or until the event happened. Okay, first wet day. So that means this is actually a geometric progression. All right, so geometric progression for part B, you can write it out, geometric progression, and then the P will be the probability for a wet day on any particular day, which is 0.16. Okay, so now they said the first wet day is on 8th of October. All right, so that means the first wet day is x, the number of days is x equals to 8. Okay, so x equals to 8, where on the 1st of October, it is a dry, not a wet day, so it is a dry day, so it will be 0.84. On the 2nd of October is also the same, which is 0.84. It is not the wet day also. So you continue to calculate first day, 1st of October, 2nd of October, 3rd of October, until 7th of October. Therefore, you need to power 7. You take the 0.84, power 7, and then on the 8th of October, finally, it is a first wet day. So you multiply it with 0.16. All right, so correct to 3 significant figure, your answer should be 0.0472. All right, so for these two questions, generally you need to identify the distribution of the x by yourself. Okay, so for part A is binomial distribution, and the second part B is actually the geometric distribution. All right, so let's continue to part number C. Okay, so for part number C, they are saying that for 4 randomly chosen years, okay, so please focus on the unit here, it is years. Find the probability that exactly one of these years. So again, this is keyword. Now they are more concerned about the years. Okay, the first wet day in October is 8 October. Okay, so now if you look at the structure of the question again, you are having 4 years, and then one of the year something happened. So generally this structure is still belongs to binomial distribution, but instead of concerning about the wet day, they are now more focused on the years. All right, so you can write it out if you want. So y, I will change a variable here. So y is binomial distributed. So now y is actually the number of years, okay, 4. And then what is the probability that you should put in the second parameter? You should put in the probability of first wet day in October is 8th of October. And this probability, you already get it just now from part number B. Okay, and 0.0472 is actually the simplified answer. So for me, right, if I want to get the most accurate answer, the P here, I will still keep it as 0.84 power 7 multiplied with 0.16. Okay, and then next, what is the probability that they want us to count? So they want us to calculate the probability of y equals to 1 year. So it will be 4C1. This is my P, so P power 1. Then Q is 1 minus P. Power 3. Okay, all right, so you can see that I keep the original form of the P. Now, if you want to write it out as 0.0472, of course you can, but when you press the calculator, try to press the original long value. All right, the long value, if you didn't do any careless mistake, you should get 0.163350495. And correct to three significant figure, it should be 0.163. Okay, so to me, the challenging part for this kind of question is you need to know how to identify the binomial distribution question and also the geometric distribution question. Right, so this is what we have for question number 5. Okay, so question number 6. All right, so they are talking about the times taken in minutes to complete a particular task by employees at a large company. So are normally distributed. So the first keyword here, which is very important, is normally distributed. Okay, so they give you the mean and also the standard deviation. Right, so for part A, they want you to find the probability that a randomly chosen employee takes more than 28.6 minutes to complete the task. All right, so for this one, it is actually normal distributed. The mean is 32.2 and the variance should be 9.6 squared. Okay, and then they want you to calculate the probability for x more than 28.6. Okay, so since this is a normal distributed variable, okay, so to find out the probability, you actually need to standardize it. So how to standardize it is you make it as x minus the mean minus 32.2, then divided by the standard deviation, which is 9.6. Right, and from here you will get a value which is negative 0.375. Right, so just a small reminder here, when you are trying to calculate this z value here, please make it into 3 decimal place, because for our table, right, so the probability that they allow us to find out for the value of z is 3 decimal place. Okay, so for this one, okay, z greater than negative 0.375, the area or the probability is actually same with z smaller than 0.375. Okay, so from the normal distribution table, you try to find out the value straight away lah. All right, it is very straightforward, so it should be 0.6462 from the table, and if you want, you can change it become 3 significant figure, which is 0.646. Right, so this is what we have for part A. Okay, so then we can continue to part B. Let's have a look for part B. Okay, so for part B, they are saying that 20% employees take longer than T minutes to complete the task. So find the value of T. Okay, so the 20% here in this case is actually the probability. All right, and then employees take longer than T minutes to complete the task is 20%. So that means when you try to change it become symbol, it will be the probability of x greater than T minutes, it should be equals to 20%. So convert to decimal place, it will be 0.2. All right, so this is the information given, and they actually want us to find out the value of t from this information. Okay, right, so again, because x is normally distributed, right, so you have to change it become z by standardize it. So when you standardize it, it should be z, it should be the value of x, which is t minus 32.2, okay, divided by 9.6, and it is equals to 0.2. Okay, so when I'm having this kind of symbol or equation, right, I will try to draw a graph, okay, to visualize it, right? Okay, so first I can see that this is a small area. 0.2 is a smaller area, not more than half of the graph, right? So I consider it as a smaller area, and this is greater sign. So that means the area on the right hand side of a particular value should be equals to 0.2. And if I draw the graph, okay, so it means that my value of z will be here, and then this area is actually 0.2. Okay, all right, so this is the correct graph that we should have now. Okay, then now I want to find out this value of z. What is this value of z? So you need to find out from the normal distribution table. Okay, right, so I will take it out, the normal distribution table here. All right, so you need to be aware that this one is actually the probability. So you want to get the answer from the probability given. Okay, so the probability given is actually this part. Right, and then the value of z, this is the value of z, right? So the value of z will be here. Okay, all these are the value of z. Right, so you have to be very clear how to use the table correctly. Yeah, okay, so now let's come back to the probability part. Okay, if you look at the probability area here, the green color part, you will realize that there's no value. Okay, so there's no value from this part. It will be equals to 0.2. Okay, so all the value here provided in the formula booklet, right? It should be more than 0.5. The smallest value is 0.5. Can you see that? And then you're getting larger and larger until 0.9999. Okay, so how can I get the exact value for 0.2? So for this case, you just take 1 minus 0.2. We try to use the complement area, okay, for 0.2. So 1 minus 0.2, you get 0.8. So instead of 0.2, right, we are looking at the 0.8 to get the exact value. Okay, all right. So now, where is the 0.8? So again, a reminder, the 0.8 is the probability, not the exact value. So you cannot straight away look at the 0.8, then you tell me that the exact value is this one. This is wrong. Okay, instead you should try to find it out in the opposite way. So that means from the probability side, from this part, get the 0.8 and then read the exact value outside. So where is 0.8? So let's have a look. Try to find one number which is closest to 0.8. So I can see this is the closest value, 0.7995, right? And you want to get 0.8000. Okay, so for 0.7995, you get the exact value, which is 0.84. Okay, but you need to add a 5. You need to add a 5 to 0.7995 at the last digit here, okay, to get the 8, to get the 0.8, right? So when you add the 5, right, you read back the value, it should be 2. So eventually you should get 0.842 as your exact value. So it means that t minus 32.2 divided by 9.6 should be equals to 0.842. Alright, so once you decide the exact value already, now you go back to your graph and have a look. This value of z should it be positive or negative? So the center here is a 0, so z is on the right hand side of 0. Okay, so which means that the z should be a positive value. So the value here should be positive 0.842. Right, so this is how we get the correct z value from the normal distribution table. Okay, all right. So now continue from here. Please try to continue to get the answer for t. Okay, so to get the value for t, okay, so to get the value for t, you just try to move all the number to the other side. You should get 40.2832, and correct it to 3 significant figure, it should be 40.3, and then it is in minutes. All right, so this is actually the answer for part B. Okay, so we continue to part C. Okay, so for part C here, they are saying that they ask you to find the probability that the time taken to complete the task by randomly chosen employee differ from the mean by less than 15 minutes. Okay, so for this question, right, to me, I will highlight the keyword which is differ. Okay, so again, they want you to find the probability, right? Okay, so differ means difference. So when you see the word differ or difference, means that it can come from two directions. That means it can be um, using the time, the difference between the time and the mean. Okay, so time is x, mean is 32.2. So they said the difference between the time and the mean, right? You can write it as x minus 32.2. You can also write as 32.2 minus x. So because that's the difference, the difference between these two variable or these two things, right? So it can be x minus 32.2 or 32.2 minus x. So to write out in a correct way, usually I will put a modulus. So the modulus here means that it can comes from both directions, right? So the keyword will be differ. So differ always mean that it comes from two directions. And then less than 15 minutes means that the difference is less than 15 minutes. So this is how usually I will try to write out the uh, symbol when it involves the question with the keyword differ. Okay, all right. So before we continue, you should know actually that for any modulus function or inequality, such as modulus x smaller than a, when you want to expand it, it will become x is between the negative a and a. So the same thing happened for our probability here. All right, so I will expand the modulus and it will become negative 15, then x minus 32.2 smaller than 15. Okay, and after that, because again, this is actually a normal distribution question. Therefore, you still need to change your variable become z. Okay, so to change it become z, you need to minus the mean. And you will realize that the minus 32.2 that you write out in the symbol is already minus the mean. So you don't need to do anything. You just need to do one extra step here, which is divided the standard deviation. So what is the standard deviation here? It is actually 9.6. Correct or not? So you do the same thing for all sides of the inequality. Negative 15 divided by 9.6. 15 divided by 9.6 also. All right, so if you try to correct it to three decimal places, you'll get negative negative 1.563 smaller than this middle part here is actually your z, something that you already standardized it, right? Because from here you can see that it is negative 32.2 means minus the mean divided by 9.6, which is the standard deviation. So the whole variable here is actually the z, and then smaller than 1.563. Okay, all right, then now what is the next step? So for the next step, you actually want to find out the probability that is between negative 1.563 and also the 1.563. Okay, so this is the area that you want to find out. Okay, so after this step, right, there are many possible ways for you to get an answer actually. Okay, some students might want to take 1 minus the area at the both end. Okay, some might want to take 1 minus the area at the both end also can if you want. Right, so for me, I will generally using this one. So I'm using z smaller than 1.563. When I'm having z smaller than 1.563, it means that this area, the green color part. Okay, and then I will minus the probability of z smaller than negative 1.563. So when I minus this z smaller than negative 1.563, it means this purple color part. So you can see that the green color part, okay, minus the purple color part, I will get the area that I want. Okay, so this is the method that I'm using here. All right, so what is z smaller than negative 1.563? So you can find out the value from the normal table. Okay, so maybe for me, I will try to put it smaller. Hopefully you can see it. All right, so I'm looking for z is smaller than 1.563. So you look for the z lah. So z 1.56 will lead you to this value here, 1.56, and then 3 will give you this value 4. Okay, so that means you take 9406 plus 4, and therefore you get 9410. So that means this will be your probability 0.9410 minus. Then for z smaller than negative 1.563, you will see that it is actually similar, okay, to 1 minus 0.9410. Okay, then you just try to press calculator, and this will lead you to the final answer, which is 0.882. Okay, so this is how we actually get the answer for question number. Okay, so now we come to the very last question for this paper, question number 7. Okay, so for question number 7, they give you the distance in meter traveled travel to school by the children, 140 children. Right, so they give you a table. All right, so we are having the distance and also the cumulative frequency. Then for first part, they actually want us to draw a cumulative frequency graph to represent these results. All right, so they already give us all the details here. Okay, so that means you just need to follow the details now. Right, so we are having 200 to 1600. Right, so you just need to make sure that you are using the correct scale, okay, for the graph. Right, okay, so let us start now. For the x-axis, I want to include until 1600, right? So it should be something like this. So this might be 200, 4, 6, 8, 1000, 1200, 1400, and 1600. So it is just nice. You can fit in nicely. So this is actually distance in meter. Alright, so for my y-axis, we need to put in the cumulative frequency. Alright, so for cumulative frequency, the highest value here is 140. So again, the scale that I'm using is this is 20, then 40, 60, 80, 100. Then we are having 120, then 140. Okay, so maybe I put it here, 140. All right, okay, and this is actually the cumulative frequency. All right, so on the graph paper, you try to plot, okay, plot all the single points here. So of course, the very first point is you should start from 0, and also the 0 for cumulative frequency. So this is the first one. All right, then for the next point, it will be 216. So you go to the 200 and you measure roughly where's the 16. So to me, it should be this point. All right, then the next point will be 346. So 300, then 46. Okay, 588. So 588 should be this one. All right, so for my graph, it might look a bit too small. All right, so if you just draw it on the graph paper, it should be just nice. All right, so after the 500 will be 900. So 900 for 1 to 2. So 900 is here. 122 should be somewhere here. Okay, 1200 should be 134. 130. So this is 134. And 1600, you will have 140. Okay, so these are the points that I plot. Okay, so after you plot all the points clearly, then you try to join them together, okay, to form a cumulative frequency curve. Okay, so if you can, you try to just to draw it smoothly. All right, and you are allowed to use ruler to draw straight line between each of the points. Also no problem. All right, so this is my cumulative frequency curve for part A. All right, okay, then now after you sketch it, just make sure that you label the x and y axis clearly. This is the y axis, this is the x axis. So please make sure that you label them clearly and the curve that you draw is smooth, or you can use ruler to join all the points together slowly, point by point. Okay, so you're allowed to do so. Okay, then now we continue to part number B. Okay, so for part number B, they actually want you to use the graph to estimate the interquartile range of the distance. Okay, so for interquartile range, you need Q1. So Q1, where's the location or position of Q1? So for Q1, you need to take 140, which is the n, divided by 4. So you get 35. Okay, and then for Q3, you need to take 140 divided by 4, then multiply with 3, and you get 105. Oh, so what is the use for this 35 and also the 105 here? So for 35 means that on your graph, on your own graph, right? Okay, so you try to look, okay, you try to find out where is the 35. So 35, this is 30 lah, the green color part here is 30. So 35 should be somewhere here. Okay, so from 35, you try to draw a horizontal line, touch the graph that you draw, and then you try to figure out what is the value here. Okay, so this is actually your Q1. Okay, so for the Q1, all right, according to my graph, all right, my original graph that I draw, so Q1, the Q1 that I get is around 250. Okay, then now to get Q3, we will need to look at 105. Okay, so you try to measure and see where's the 105 here. Should be somewhere here. This is 105. And you do the same thing. You try to draw a horizontal line. Okay, my line here might not be very nice lah. So for your case, you try to draw it as good as possible. Okay, and then you try to read the value from the x-axis. So this will be your Q3. Okay, so for my original graph that I draw, the Q3 that I get is 670. And since they are asking for IQR, right? So for IQR will be Q3 minus Q1, and therefore the answer will be 420. Okay, so for the value that we get here, right, it is based on the graph that you draw. So everyone might have different value for Q1, Q2, and also the IQR, the Q3 and IQR. Okay, all right. So if we have a look for the, if you try to have a look for the marking scheme, okay, so you can see that for marking scheme here, they actually give you a certain range. So like for this one, the upper quartile range they give you is between 660 to 720. And then for the lower quartile, which is Q1, okay, as long as your range is between 240 until 390, then all these are acceptable. Okay, so no need to feel panic if let's say your answer is different from what I show you here. Okay, because the marking scheme will actually accept a certain range of the answer. Okay, this is due to the reason that for all the graph that we all draw, right, it might be a bit different from person to person. Okay, so this is what we have for part B. Okay, then now we continue to part C. So the part C for this question, I'll move it down here. Okay, so part C, they actually want us to calculate the estimate of the mean. Okay, all right. So they want us to calculate the mean value and also the standard deviation of the distance. All right, so from a cumulative frequency table that they provide us, and to find the mean and standard deviation, I will show you a detailed process. All right, so the detailed process means that before any calculation for the mean and also the standard deviation, I actually need to know what is my class boundary. Okay, so I will create a table, okay, to visualize everything clearly. So I will have a class boundaries. I want to list out all my class boundaries. And after that, I also want to know the frequency. I need the frequency to calculate the mean and also the standard deviation. Frequency is the F. And after that, I need the midpoint also. All right, for the class boundary, which is the X. All right, so from the first column here, from the cumulative frequency table, right? Okay, so they are saying that X smaller equals to 200 and the cumulative frequency is 16. So that means when you want to convert it into a class boundary, the value should start from 0, okay, to 200. All right, and the frequency should be 16. So the first class and cumulative frequency will be the same as the frequency. Okay, then what's the midpoint? We can calculate it later, never mind. Then now we proceed to the second column. So for the second column is X smaller equals to 300. So that means for the class boundaries, right, you should use back the previous value given in the previous class and then go to the 300. Okay, and the frequency, if you want to calculate the frequency for this class, you have to take the cumulative frequency minus the previous cumulative frequency, the previous cumulative frequency, which is 46 minus 60, and you will have a 30. So the frequency for this class will be 30. Okay, so you do the same thing for the rest. So I tried another one. Okay, so X smaller equals to 500 means that from 300 to 500, the frequency will be 88 minus 46. So 88 minus 46, you'll get 42. All right, so you do the rest of the column by having the same steps. All right, so if you continue and you didn't do any careless mistake, then your answer should look something like this. Okay, so I'm having 500 to 900. This is 34. And then 900, okay, to 1200. This is 12. And 1200 to 1600. This is 6. And for the midpoint, okay, so to get the midpoint here, generally you take 0, the lower class boundary, plus the upper class boundary, then divided by 2. So for the first midpoint here, the value is at 100. For the second class will be 250. Third one will be 400, 700, 1050, and also 1400. All right, so generally this is the table that I created to ease my process of calculating the mean and standard deviation later. All right, okay, so now let me start with the mean. So what is the formula for mean? It should be summation of fx divided by summation of f. So summation of fm means that you take the frequency multiply with the midpoint. So you should list out everything. So 16 multiplied with 100 plus 30 multiplied with 250 and so on. Okay, so you do the same thing for every single class boundary here. And then you have to divide it by the summation of f. So that means the total frequency. Okay, so the total frequency here is very obvious because they already mentioned just now, which is 140. Okay, then from here you should able to get 70700 divided by 140, and the mean that you get is 505. It's a very nice number. Okay, then now the next one will be they want you to calculate the standard deviation. Okay, so to calculate the standard deviation, right, the formula will be summation fx squared. So that means what you need to do is you have to take the frequency multiply with the square of f, the square of x. So 100 is the x, right? You square it, then multiply with the frequency. Okay, All right, then you do the same thing for the rest, 30, and then 200 square, and so on. Okay, so you repeat the whole thing, all right, until the last class, then divided by 140, minus the mean. So the mean that you get just now is 505, is exactly the nice number, all right, the whole number. Okay, then by just pressing calculator, you try to summarize your value, 5040,5,000, then divided by 140 minus 505 square. So from that, you will get a value. And of course, we want to correct it to three significant figure, which is 324. All right, okay, so this is how we actually calculate the mean and also the standard deviation from a cumulative frequency table. All right, so this table actually is to help you to visualize the detailed steps that I do. Okay, so the first I will find out the class boundary and try to calculate the frequency first, followed by the midpoint. Then only I will input all the values into the formula. Okay, so here we ended the discussion for this paper.